Today we're doing the first set of notes in radicals. This section is going to be completely new, so we're going to spend a couple days on this set of notes because this material is going to be so different than anything that we've done thus far this year. So at the top of your set of notes it says rational exponents and roots, and we have these two forms. One's in radical form, one's in exponential form, and you're going to hear me reference these two different forms periodically throughout the lesson and in class. So radical form obviously is the one that has the root. Let me switch the color. So radical form always has the root, whereas an exponential form does not have a root, it has an exponent. And if you look at these two forms are what we call equivalent or equal, so I'm able to go back and forth these two forms. So notice that the power of the root becomes the base or the denominator of our fraction. So we're just going to practice identifying that denominator value. So here you have three examples. Notice when you look at the square root of 4, you don't see a number on the outside, and that's because it's implied to be a 2. So the reason it is, like if I asked you, and this is just a side note, you don't need to write it down, if I asked you what the square root of 9 is, you would say 3, but I want to make sure you actually understand why it's 3. So the reason it's 3 is the square root of 9 can be written as 3 squared, and technically there's implied to be a 2 out there, and those 2's are what's canceling, and that's why the square root of 9 is 3. So going back to this problem, if you don't see a value outside the radical, it's implied to be a 2. So that means this value of a has to be 2, and it's easy as that. So for letter B, again, our root number is 3. So the base of the denominator of the fraction is 3. And for the last one, it's the 4th root of 81. So our value of C is 4. So let's move on to, let's kind of step it up a notch. So in the next example, it says rewrite. So here I have the 5th root of x. So this will become x to the 1/5 power. Again, we were in radical form, I put it in exponential form. Skip to the last one, I have a square root of m, and again, it's implied that there's a 2 there. So I would say this is m to the 1/2. I'm going to have you try the cube root of a as your question right now. In the next section, I'm in exponential form, and I'm asking you to write it in radical form. So this will become the 4th root of 5. So go ahead and try 20 to the 1/2 power for your question. So that was very basic. We just had all of our bases underneath the radical were raised to the 1st power. So now that you have the general understanding, we're going to kind of step it up a notch. So there's two forms to the radical form, and again, you can see this in that little box in your notes. I have the nth root of a to the m power, and this is also the same thing as saying the quantity of the nth root of a raised to the m power. So notice the placement of this m does not really matter, and both of these forms are equal to a raised to the m over n power. So again, notice that whatever the root number is still the denominator. It's just whatever your base is raised to that becomes the numerator of your fraction. So we're going to just try again a couple of these where we step it up a notch. So here we are in radical form, and I want you to rewrite this in exponential form. So the way we pronounce this is the 5th root of x to the 4th. This becomes x to the 4/5. The next one, I have the quantity of the square root of m to the 5th power. Again, I know it's implied to be a 2 there, so this is m to the 5/2 power. So go ahead and try in your question rewriting the cube root of a squared. And here we have d to the 3/4 power, so I want to write this in radical form. So I have the 4th root of d cubed. So go ahead and try y to the 7/2 powers, putting that in radical form. So the next thing, again, we're going to spend lots of time on this tomorrow practicing, is all the different properties of exponents. This is something we should have learned in Algebra 2, or in Algebra 1, sorry. I don't know how much time you spent on it in Algebra 1, so we're going to have to kind of go back and revisit all these basic properties before we can kind of step it up a notch and apply it to an actual Algebra 2 lesson. So I want us to label as we go, so that way when I reference these, you know what I'm talking about. So this first one is multiplying with same base. And notice in the rule, I'm multiplying. I have a to the m, a to the n, and when I have the same base, I add my exponents. So right here, they add the exponents to keep the base. So for an example, I have 8 to the 1/3 times 8 to the 2/3. So I keep the 8, and I'm doing 1/3 plus 2/3. And in order to add fractions, we need common denominators, which we do have. So I would say this is 8 to the 3/3. And I know that can reduce to the first power, so the final answer is just 8. So for our next example, this is what we would call a power to a power. And you're going to hear me, like I said, especially during board work, I'll kind of reference these different rules and say, okay, we're working on power to a power. So that's why we're going to kind of label these. So the rule says if I have a to the mth power raised to the nth power, then I multiply the exponents. So here, I'm raising 5 to the 1/2 power to the 4th power. Notice, I know you might be tempted to say, well, 5 to the 1/2 power is the square root of 5. This is true. However, these rules only apply when you have an exponent. So I never want to have these in radical form. I always need to have them in exponential form to utilize the rule. So this will be 5 to the 1/2 times 4. 1/2 times 4. We do not need common denominators to multiply. We multiply straight through top, straight through bottom. So this is 5 squared, which is 25. The next one, we could call this, let's see, a quantity, or how about we'll say a product raised to a power. So product to a power. So notice A and B is what our product is. A and B would signify two different bases. It could be a number and a variable or two different variables. And the whole quantity is raised to an exponent. And when I have that case, notice that they both get the exponent themselves. So right now, 4 is raised to the first power, 5 is raised to the 5th power. So if I applied this rule, I would say that this is 4 to the 1/2 power, and then times 5 to the 1/2 power. And now this is where we want to bring that, what we just did on the front page, back. So this is the square root of 4 times the square root of 5. And I know I can simplify one of them to be 2 root 5. All right, so our next rule is negative exponents. So, and you also might want to like kind of draw a line. So these three kind of are all similar. They're all dealing with multiplication of some sort. So the next one is a negative exponent. So notice if I have a to the negative nth power, it becomes 1 over a to the m. So a negative exponent simply just changes its place in the fraction. So if it's a negative exponent, I drop it down to the bottom. So here I have 9 to the negative 1/2. So I can rewrite this as 1 over 9 to the 1/2 power. So notice by dropping it down, I've now dropped the negative. And now I can say this is 1 over the square root of 9, using what we learned prior to this. And the final answer would be 1 over 3. So that's how negative exponents work. Again, we will do a ton of practice and board work on these concepts tomorrow. Our next one, we will call dividing with same base. So this is dividing with the same base. And this is kind of similar to the first one. The first one was multiplying with the same base, and I added the exponents. So now when I'm dividing with the same base, notice we subtract the exponents. So here I'm dividing, I have 7, so I have the same base, so I'll say this is 7 to the 3/2 minus 1/2. I have those common denominators, so I have 7 to the 2/2, which again is 7 to the first power, which is 7, so we're done. And the last one is a quotient to a power. So a quotient to a power. And this rule says if I have a quantity being divided, I give them each their own exponent. So this will become 5 to the 1/3 power over 27 to the 1/3 power. And using what we just learned, this is the cube root of 5 over the cube root of 27. And cube root of 5 stays. Cube root of 27 is 3, because 3 times 3 times 3 gives me 27. So that's all for today. We're going to pick up with this lesson tomorrow, and we're going to do a ton of practice.